Welcome to Chem Camp with Mrs. Newman. Today, what I'd like to discuss is the significant figure rule pertaining to calculations involving the multiplication and division of measurements. Let's do some chemistry. The rule simply states that the answer to a calculation involving multiplication and division can have the same number of significant figures as the measurement with the least number of significant figures. Let's apply this rule to letter A. In letter A, the calculation they give us is 2.74 times 3.008 times 4.4. And the answer the calculator gives us is 36.2644448. Now, since this calculation involves measurements, we cannot keep all those numbers in that answer. So what we have to do is analyze each measurement to determine how many sig figs each one has. So in the 2.74 centimeters, they're all non-zero digits, so that gives us 3 sig figs in that particular measurement. In the 3.008, there's 2 non-zero digits and 2 trapped zeros. Trapped zeros are always significant, so that gives us a total of 4 sig figs with that particular measurement. Finally, in the 4.4 centimeters, we've got 2 non-zero digits, always significant, so we have 2 sig figs there. 2 is the least amount of sig figs. That indicates that out of all of those 3 measurements, that last measurement is the measurement taken with the instrument with the least precision. And this particular measurement is going to limit the number of sig figs we can have in our answer. So since it only has 2 sig figs for that measurement, we can only have 2 sig figs in our answer. Now the 3 and the 6 in our answer, they're both non-zero digits, so they're going to be significant. We're going to look just one number past that 6, however. It's a 2, which is less than 5, so we're going to round our answer to 36. And since we did centimeters times centimeters times centimeters, the unit on that answer should be centimeters cubed. Let's try B. In letter B, they have us take 7.895 grams and divide it by 34.0 milliliters, which gives us an answer of 0.23220588824 in our calculator. But once again, we cannot keep all those numbers. We have to figure out how many sig figs are in the measurements in the calculation. So in that top measurement, there's 4 non-zero digits. So we have 4 sig figs. In the bottom measurement, 34.0, the 2 non-zero digits are significant, and that trailing 0 is significant because there's a decimal point in that measurement. So we have 3 sig figs. 3 is less than 4, so we can only have 3 sig figs in our answer. However, we have to be careful. Our answer has a leading 0 in the front of that number. Keep in mind, leading zeros are never significant. So the 2, the 3, and the 2 are going to be our 3 sig figs. We're going to look one number past that last 2, and it's also a 2. Which indicates we're going to leave our answer as 2.32 grams per milliliter. Since the operation here is division and those are different units, both of those units have to be included on the unit of your answer. Let's try C. In letter C, they have us take 24.8 meters times 825.96 meters. That gives us an answer of 20,483.808. Let's take a look at how many sig figs are in our measurements. In the first measurement, we have all non-zero digits. That gives us 3 sig figs. And in the second measurement, we also have non-zero digits only. So we've got 5 sig figs there. So that means we can actually only have 3 sig figs in our answer, which is going to make rounding this answer a little bit tricky. So follow along. We've got 3 sig figs here. So the 2, the 0, and the 4 are all going to be significant. We have to look one place beyond that 4. This time it's an 8, which is greater than 5. So that means we're going to round that 4 to a 5, which should give us 205. Now we just have to be very careful. We cannot round a number like 20,483 down to 205. We have to still have those last 2 places in our number, but they have to be filled with a digit that's going to be insignificant. So I'm going to put 2 zeros there to hold that place. No decimal point though at the end of that number, because we need those zeros to be insignificant. If you put a decimal point at that number, you're going to have those 2 zeros become significant, and then you're going to have a total of 5 sig figs, which we don't want. So this answer is going to be 20,500 meters squared. Other option here is we could also place that answer in scientific notation and not have to worry about those last 2 trailing zeros. So we could also report this answer as 2.05 times 10 to the 1, 2, 3, 4th, and then add our meters squared. We've got one final one in letter D. We're going to take 0.075 and divide it by 0.0320. The number we get in our calculator is 2.34375. Let's check sig figs though. In the first measurement on top, the first 2 digits are leading zeros, so they're never going to be significant, but the 7 and the 5 will be. So we've got 2 sig figs there. And the bottom measurement, we've got 0.0320. First 2 zeros are leading zeros, not significant. The 3 and the 2 are going to count, and that trailing 0 is also going to count because there's a decimal place there. So we've got 3 sig figs on the bottom. 2 is the least number, so we can have 2 sig figs in our answer. We're going to look one past that 3. It's a 4, which is less than 5. So we're going to report this answer as 2.3 grams per centimeter cubed. I hope this video helps you with your sig figs and calculations. If you're struggling with how to determine the number of sig figs, be sure to go back and watch some of my other videos on the other significant figure rules. Continue to follow along for more chemistry content.